-1 to 1, 0 to z, x minus z to x plus z. It is x plus, function is x plus y plus z, dy dx dz. What will be the first variable, guys? Which is this variable varying?
Y.
Yes, because we have x and z here, so it must be y variable is varying from x minus z to x plus z. What will be the second one?
X.
X.
Obviously it is x because y is already done, and here we have z, so it must be x varies from 0 to z. And the last one is z.
Z.
Yes. So we have to integrate with respect to y first. When you integrate with respect to y, x is a constant, so we have to multiply y. And y will be y square by 2. Z is a constant, so we have to multiply y, which is equal to integration of z equal to -1 to 1, x is equal to 0 to z, and now integration of x with respect to y is x into y, it is y square by 2 plus z into y, and the limits are x minus z, x plus z, dx dz. Now in place of y we have to substitute x plus z and x minus z. In place of y, x plus z, x minus z, in place of y this. So let us substitute both limit in first term, then second term, then in the third term. Is equal to z equal to -1 to 1 and x equal to 0 to z. First term, if I keep x as it is, if I substitute in place of y, it is x plus z, the upper term, minus x minus z. Okay, let me close the bracket. Plus, so 1 by 2, I'll keep it outside. Now x plus z the whole square minus x minus z the whole square. X plus z the whole square, x minus z the whole square. Correct? Let me close the bracket. Plus, what is the last term? Bracket z, x plus z minus x minus z. Okay, it went other side. Please, it is very clear. In place of y, I am substituting the upper limit and the lower limit. In place of y, 1 by 2 I kept outside. In place of y, again upper limit and the lower limit. Plus z as it is. In place of y, upper limit and lower limit. So what are the terms are getting cancelled that you need to check here? Minus x plus x. Here also the term which is getting cancelled is, see, we have to write it in the bracket. Let me remove that. Here also x and x get cancelled. Okay. So which is equal to z equal to -1 to 1, x is equal to 0 to z. First term, here it is z minus minus plus 2z is remaining. Shall I write x 2xz? Z and z it is 2z and x is remaining. So 2xz is the first term. Plus keep 1 by 2 as it is. Now expand this x a plus b the whole square. X square plus z square plus 2xz minus x square. It is again a minus b the whole square, which is a square plus b square minus 2ab. So it is x square minus z square plus 2xz. Bracket close. Plus here z and minus minus plus z. So it is 2z square. Okay, I missed dx dz. So let me write that dx dz. Okay. Now, please try to understand these two steps. And if you did not get these two steps, please ask. Please ask. I'll repeat. X and getting cancelled. My plus z and minus minus plus. It is 2z. So x, 2xz. I have expanded this term a plus b whole square and expanded this term a minus b the whole square and applied the negative sign inside. Here x and x get cancelled, minus minus plus, so it is 2z into z is 2z square. So what are the terms are getting cancelled in this term?
X square, Z square.
Yes, x square, z square, x square. What is remaining? 4xz.
4x.
So is equal to z equal to -1 to 1, x is equal to 0 to z. In bracket, already we have 2xz plus 1 by 2, and remaining is 4xz plus 2z square dx dz. Now 2 2s are 4. So 2xz, 2xz, it is 4xz. Z equal to -1 to 1, x is equal to 0 to z. So we have 4xz plus 2z square dx dz. Dx dz. Now we have to integrate with respect to, x. Yes. So x is, here we have x, but here we don't have x. It is a constant term. So we have to multiply x here. Here it will be x square by 2. So let me simplify that, which is equal to integration of z equal to -1 to 1. It is 4 x square by 2 z plus 2 z square into x, and the limits are 0 to z. Means in place of x we have to substitute z. Here 2 2s are 4. So what is remaining, guys? 2 z square z. 2 z square z, because in place of x we have to substitute z. So 2z square into z is 2z cube plus 2z square into z is 2z cube. So it is 2z cube plus 2z cube. No need to substitute 0, because if you substitute 0, it is 0. What is remaining? 4z cube dz. What is the, sorry, 4z cube dz. Okay. Now if you simplify, what you get? Z details, z cube. What is the integration of z cube?
Z 4 by 4.
Yes, z 4 by 4, but 4 get cancelled.
So Z 4.
Z to the power 4. And if you apply the limit -1 to 1 to z4, what you will get the answer?
2 sir, 2.
Check again.
Two, sir. It will be 2 answer.
No.
So minus.
0.
Yes. It is 0, right?
Yes, 0 will be 6.
Yes. See what will happen? Z to the power 4 means 1 to the power 4 is 1. -1 to the power
Minus
4 is 1. Because -1 to the
minus 1
power
power
4.
4 is
Minus
1.
of -1. The answer is 0.
Oh my god.
Yes. I hope all of you got the answer.
Yes, sir.
Good. So please go through the problem from the beginning. One who did not understand, once again check. Then if you have any doubts in any step, please ask.
No doubt, sir.
Good. Today I will give you the homeworks, workout problems. I'll clear all drawings. Okay. So take the second problem of today's class. Evaluate integration of 0 to a integration of 0 to x and integration of 0 to x plus y e to the power x plus y plus z dz dy dx. This is I is equal to, what is the first variable here from this side?
Z.
Yes.
X,
This is
Sorry.
Z,
Z, sir.
this is,
Y,
and this is.
X.
X.
So x is equal to 0 to a, y is equal to 0 to x, z equal to 0 to x plus y, e to the power. And remember, you need to integrate first with respect to z.
Yes.
And we know that e to the power x plus y plus z can be written as e to the power x plus y into e to the power z. Is this correct?
Yes, sir.
I can split
Yes,
the
sir.
term because the base, I can, with respect to the base, I can split the terms. It is one and the same. So I can write this as e to the power x plus y, e to the power z, dz, dy, dx. Because when you are integrating with respect to z, this is the constant term. So we have to keep it as it is. We have to integrate only e to the power z. Okay. So let us integrate with respect to z first. X equal to 0 to a, we are keeping as it is. Y is equal to 0 to x, we are keeping as it is. Now e to the power x plus y, we are keeping as it is because it is a constant. E to the power z integration is e to the power z itself. The limits are 0 to x plus y, dy and dx. E to the power x plus y, we keep it as it is. Integration of e to the power z is e to the power z. Limits are 0 to x plus y, dy dx. In place of z, we have to substitute x plus y, and then we have to substitute 0. Integration of x equal to 0 to a, y is equal to 0 to x, e to the power x plus y outside. In place of z, if I substitute x plus y, we'll get e to the power x plus y. And what is e to the power 0? If I z is replaced by 0, what is e to the power 0?
1.
1.
1.
See, remember in exponential, see, if it is any other term, any other function of x or polynomial, then we no need to write the second because it becomes directly 0. But if it is an exponential term, don't leave this lower limit because e to the power 0 is 1. Now, before integrating next, just multiply. Simplify this. Multiply this inside. Integration of x is equal to 0 to a and y is equal to 0 to x. E to the power x plus y, e to the power x plus y. So I can write e to the power 2x plus
2x.
2y because x plus x is 2x, y plus y is 2y minus e to the power x plus y dy dx. Now you integrate with respect to y. And remember, when you are integrating with respect to y, e to the power 2x is a constant. Here e to the power x is a constant. You have to integrate only e to the power 2y here and e to the power y here. Okay, do it. Integration of x is equal to 0 to a. First term e to the power 2x as it is. And integration of e to the power 2y is e to the power 2y divided by 2. The limits are 0 to x minus e to the power x as it is, e to the power y is e to the power y, 0 to x. E to the power 2x is a constant. E to the power 2y integration is e to the 2y divided by the coefficient of the variable is 2 minus e to the power x as it is, e to the power y integration is e to the power y, limits are 0 to x. Now substitute these limits in these integrals. is equal to x is equal to 0 to a e to the power 2x by 2. I'll take that 2 outside. First will be e to the power 2x. Second will be e to the power 0, that is 1. Minus, it will be e to the power x in bracket e to the power x minus 1. It is dx. Now simplify these terms. Simplify these terms. So e to the power 2x into e to the power 2x, it is e to the power 4x divided by 2, x equal to 0 to a, e to the power 4x divided by 2, minus e to the power 2x divided by 2, minus e to the power x into e to the power x is e to the power 2x, minus minus plus e to the power x. And just multiplied these terms inside. E to the power 2x into e to the power 2x is e to the power 4x by 2. E to the power 2x by 2 into 1 is e to the power 2x by 2. Minus e to the power x into e to the power x is e to the power 2x. Minus minus plus e to the power x into 1 is e to the power x. Now we can simplify. These two are the same term. E to the power 2x, e to the power take. Take the LCM. LCM is 2. So here you have to multiply 2. Minus 1 minus 2 is minus 3. So before integrating x equal to 0 to a, e to the power 4x by 2 minus 3 e to the power 2x by 2 plus e to the power x into dx. Now you can integrate e to the power 4x integration. What is e to the power 4x integration, guys?
E to the power 4x by 4.
Yeah, 2 into 4 because already we have 2. So 4 is here. Minus 3 by 2 already we have. E to the power 2x integration is e to the power 2x by 2 plus e to the power x is e to the power x. And limits are 0 to a. Now apply the limits and tell me what is the answer. First apply in place of x a, then apply in place of x 0. E to the power 4a by 8, 3 by 4 to the power 2a plus e to the power a. And if I apply 0, 1 by 8, 3 by 4. What's the answer? 4a by 8 as it is, 3 by 4 e to the power 2a as it is, e to the power 2a as it is. What is this? Minus 1 by 8 minus 3 by 4 plus 1. LCM is 8. 4 minus 3 by 8.
3 by 8, sir.
Yes, good. Three by 8. So this is the answer. You can keep this as answer. Further simplification you can do by taking 1 by 8 outside, but not required. You can keep this as answer. So all of you again go through the problem and check in any step. If you have any sort of doubt or anything, you can ask.
Sir, can you explain the first line once again? Why do you split that from?
Yeah, see, either if you want, you can split it. Otherwise, you can keep it as it is. It doesn't matter. But I split it because we need to substitute this limit as well. Okay. So we split it as e to the power x plus y into e to the power z because these are same. For our integration, we splitted it so that we can easily integrate this and we can substitute these limits. Clear?
Okay, sir.
Sir.
Any doubt, or shall I go for the next problem?
Sir, in the second part, third line, please explain it again.
Which one?
Second part, this,
Second part.
yeah, third
This
line.
one. This one you are asking?
Yeah.
Okay. So, okay, fine. Now, here, till here, the simplification of the first integration we got here. Now, when we are integrating with respect to y, there are both the terms we have, e to the power 2x as well as e to the power 2y. So we have to keep e to the power 2x as it is when you integrate with respect to y. So we kept this term as it is and we integrated with respect to y. So e to the power 2y divided by 2 is the integration. 0 to x is a limit. Here also we have two terms, e to the power x one term, e to the power y one term. So e to the power x, keep it as it is, integrate e to the power y. See, we can split this term. I did not write one extra step here that shows the splitting of this. I have directly written e to the power x as it is and integration of e to the power y. Then we need to substitute these limits. So if you substitute x in terms of y, so it is 2x, and 0 if you substitute, it is 1. And remember, the constant 1 by 2, I took it outside, that is e to the power 2x by 2. And here, in place of y, if I substitute x, I'll get e to the power x. And in place of y, if I substitute 0, I'll get 1. So this is, so we have to multiply this. E to the power 2x into e to the power 2x is, bases are same, add the powers. If you add the power, it is 4x. And e to the power 2x by 2 minus 1 is same as it is. Again, when you multiply minus e to the power x into e to the power x, bases are same, add the power, so x plus x is 2x. Minus minus plus e to the power x into 1 is e to the power x. Simplify, taking the LCM. See, these two, e to the power 2x as well as e to the power 2x. The LCM of these two is 2 is the LCM. So here we don't have 2, so we have to 2 multiply here. So it is minus 2 e to the power 2x. Minus 2 e to the power 2x minus e to the power 2x is minus 3 e to the power 2x by 2 plus e to the power x. Now just integration is remaining. E to the power 4x by 4, e to the power 2x by 2, e to the power x, and 0 to a is the limit. If we substitute a here, we get this answer.
Okay, sir. Thank you.
Yes. So shall we go for the next problem?
Yes, sir.
Yes, sir.
Okay. This problem is, you check the question, you will understand. I want you to answer, and I want you to understand how to solve this problem. Is this the third one, right? Evaluate 0 to 1, 0 to square root of 1 minus x square. 0 to square root of 1 minus x square minus y square dz dy dx whole divided by square root of 1 minus x square minus y square minus z square. Okay, think about this problem, how to solve. Wait a minute. Okay, sorry guys, I got an important call. Just okay, tell me guys, how can we solve this problem? Do we have any direct formula for these type of problem in integration? You're there, guys?
Yes.
Yes, sir.
Yes,
Yeah.
sir.
Do we have any direct formula for these type of problem? If yes, I want to know. If no, then what we have to do? How do we have to solve? See, I can solve problem. I can take a substitution or whatever I can do, I can solve the problem. But when I use substitution and all, you may not understand why that particular substitution I am using. So if you think and tell me the substitution, I may help you that how to choose the substitution. So first thing you need to identify that in integration, there is any formula of 1 divided by square root.
1 divided by 1 minus x square is a sin x or something.
Yeah, great, good. There is a formula, right? 1 divided by 1 divided by square root formulas are there. Okay, but we have a formula something like this: 1 divided by square root of a square minus x square, or 1 divided by square root of 1 minus x square, which is sine inverse x. This is sine inverse
Yes.
x, right?
Yes, sir.
Yes, sir.
And what about this? X by a, correct? See, now first thing, can we convert this to 1 minus x square form? Can we convert the denominator into the form of 1 square root of 1 minus x square?
Yes,
Hmm?
sir.
See, for example, if I take all the term, this x square minus y square, z square as k, so that will be a constant, which is a function of a 3 variable, correct? But what about the limits? Limits will be the same. What if we convert this in the form of square root of a square minus x square? You need to think now how we can convert this denominator into this form.
By taking minus common from x square, y square, z square and making it k square.
By taking
Minus common. 1 minus bracket x square plus y square plus z
so you're
square.
asking, you are telling that you can convert it to square root of 1 minus 1 term the whole square.
Yes, sir.
But how it will come a square? How it will become a square?
Oh, square.
Yeah, that is what, no? How it will become a square? There is nothing, you need to just rewrite this denominator. It's very simple, just you have to rewrite this. See, how can we rewrite this? Can we write this as square root of 1 minus x square minus y square minus z square is equal to square root of 1 minus x square minus y square whole square minus z square. Is this correct? Equal both?
Yes, sir.
See,
Yes,
here
sir.
I have taken the square root extra, and again I have taken the square also, but square root and square get cancelled. The remaining term is 1 minus x square minus y square. Now the thing is, why I have taken only this as a particular term, whole square? That is also a question, right? I could have taken 1 minus, then square root of x square minus y square plus z square to the whole square also. But why this 1 minus x square minus y square as a substitution? You can check your limit. What is the limit you have?
Same 1 minus x square.
Same term, right? That's why. See, then what happens? What happens here? Let k is equal to square root of 1 minus x square minus y square. Then your denominator becomes k square minus z square, and your limit becomes 0 to k. So we can directly apply the sine inverse formula to write the integral. So we have I is equal to 0 to 1 and 0 integration of 1 minus x square. And what are these variables? You tell me. What will be the first variable?
Z,
Z.
Z,
Second one,
Y,
Y,
and X.
X.
Right. X is equal to 0, Y is equal to 0 to, and Z equal to 0 to K now. It won't be square root of 1 minus x square minus y square because we have taken the substitution. It has K. And remaining is dz divided by square root of K square minus Z square. Remember, see, whenever you solve an integral, either it should be a standard function of whatever the formulas we have, or else we have to use the substitution and we have to convert into a standard function. That is the main procedure of integration. So it is not in the standard function, but it is sort of in the form of standard function. By substitution, we can convert it to a standard function. So what is the integral of this? What is the integral of this?
sine inverse K by A, K by Z.
Sine inverse. Sine inverse.
K by Z, right?
K by Z or Z by K?
K, A by Z,
Mhm.
Z by K.
Yes. X by A, right? And the limits are 0 to K, dy dx. Okay. Keshwar Mohammed. All of you can hear my voice, and whether it is lagging.
Inverse Z, sir.
Whether it is lagging my voice.
No, sir.
No, sir.
Okay, okay. I think Keshwar, check your internet. There might be a problem. Okay, please ask any doubts if you have in this particular substitution.
No doubt, sir.
Okay, clear. Now let us substitute these limits. Is equal to integration of x is equal to 0 to 1, and integration of y is equal to square root of 1 minus x square. If I substitute in terms of z, k, so it is sine inverse k by k, so sine inverse 1 minus. If I substitute in place of z 0, it is sine inverse of 0. Okay, what is sine inverse of 1?
90.
Pi by 2, correct? This 90 means it is pi by 2. What is sine inverse of 0?
0.
0. So I don't write that because sine inverse of 1 is pi by 2 and sine inverse of 0 is 0, dy dx, pi by 2. Next, we have to integrate with respect to y, and you can see pi by 2 is a constant term. Pi by 2 is a constant term. So integration of dy is y. So I'll take this pi by 2 outside. Integration of x is equal to 0 to 1. Integration of dy is y, 0 to square root of 1 minus x square dx. Integration of dy, there is nothing, there is a constant, so we have to multiply y, and dx is remaining. In place of y, we have to substitute square root of 1 minus x square, and if you substitute 0, it is 0, so no need to write that. Square root of 1 minus x square dx, yes. And there is a standard formula for this, as well as you can use the substitution. Substitution you have done in the previous semester. You can easily substitute x as what? What you can substitute x as?
A sin x.
Yeah. There is no need of a because it is 1, right? So only
Okay,
sine.
sir.
Sin theta only.
You can use sine theta or you can use cos theta. You can simplify, but it is little bit lengthy. There is a one more formula, direct formula for this. Anybody remember? Direct formula for this type of terms. You might have studied in your +2 or PUC, whatever you have studied. A square minus x square dx. X by 2. A square minus x square plus a square by 2. Does anybody remember now?
Yes, sir.
It depends, because if you have studied properly the integration, then you would have remembered this formula. Otherwise, please write down this formula for reference so that we can use this formula here. See, in this formula, we have to compare. In place of a, we have 1, and x, we have x itself. So directly we can substitute these values. It's equal to pi by 2. So in bracket, x by 2 square root of 1 minus x square plus a square means 1 by 2 sine inverse of x by 1, 0 to 1. Now substitute, okay. Substitute limits and tell me the answer what you will get. Substitute the limits and tell me the answer what you will get.
Sir, pi by 8.
Is it pi? Check.
Pi
Pi
square by
Correct,
Sir.
correct,
Pi square by 8.
correct answer. Pi square by 8 is the correct answer.
Okay, sir.
See, pi by 2. If you apply 1, 1 minus 1, 0. Okay, in the first. And if you apply 1 here, it is 1 by 2 sine inverse 1. Minus. If you apply 0, 0 into anything is 0. If you apply x place of 0, sine inverse of 0 is 0. So 0, 0, pi by 2, 1 by 2 is remaining. So pi by 2 into 1 by 2 into sine inverse 1 is again pi by 2. So it is pi square by 8. This is the answer. Okay, and remember, this is one of the difficult problem in this integral, double integral to triple integral problems. Okay, they may change this variable, but similar type of problem, if they ask a difficult problem, this will be a difficult problem in double and triple integral. Okay, so we have completed double and triple integral first topic now. First topic we have covered. There are 3 more topics we have remaining. Second topic is about the region, means they will give the region, and depends upon the region we have to identify the limits. That is the second topic. Third topic is change of order of integration, how to change the order of integration. And fourth topic is change the order to polar form. Change to polar form. That is the fourth topic. These are the main 4 topics you will study in double and triple integrals. Then after that, applications like area, volume, that is the application you will study. Okay. So on this topic, I would like to give you the workout problems, and I expect each and every one of you to solve the problems. And if you don't understand, we will solve those problems in the next class. Any problem, if you face very difficulty, we'll solve in the next class. Am I clear?
Yes,
Yes, sir.
Yes,
So
sir.
shall I clear this screen and shall I write the homework problem?
Okay,
Yes, sir.
Okay, sir.
Okay, sir.
integration of 0 to 1, integration of 0 to square root of 1 minus y square, x cube y dx dy. Second one, one minus x square minus y square, x y z dz dy dx. This fourth problem, try if you can, otherwise we'll solve tomorrow. Today is a Friday,
Yes, sir.
and I will take tomorrow class, guys.
At which time? At what time?
Enough? I think that's enough. Do you want the final answer to verify?
Yes, sir.
Yeah, I will give the final answers. You can verify, okay? Last semester you studied reduction formulas, right?
Yes, sir.
No.
Sir,
Yeah.
Third one, read 4-number question. Third integration what? It is r minus r1.
The fourth one you are asking?
Yes, sir.
0 to pi by 2, 0 to a sine theta, 0 to a square minus r square divided by a square minus r square divided by a. Wait, I'll rewrite it, okay? Oh, shit. R dr d theta dz. Clear? Okay. That's done for today's class. And I have already told you I'll take tomorrow's class. And if anybody is not taking in the morning, I'll complete in the morning 11:30. Okay. Otherwise, regular time. Otherwise, the time I will inform tomorrow morning. The time of the class I will inform tomorrow morning. Okay.
okay, sir. Thank you.
Yes. Thank you, everyone. Take care. Be safe. See you tomorrow. You can leave the class.
Bye, sir.
Thank you, sir.
Bye, sir. Have a good time.
Yes, same to you.